Hello everyone, welcome back to the General Maths Unit 1, 2, and today we're going to continue with Chapter 8b, Isomorphic graphs and the connect graph and also the adjacency matrices. So we're going to using the matrices to graphing our graphs and the networks, and then also we're going to look at what's the connect graph and what's the disconnect graph looks like. Hope you guys enjoyed it, and we're gonna start right now. So connected graphs is and the bridges are connected graphs. So what's the bridges? I'm gonna make sure you guys know this one in a second. And so far we know all the graphs have the encountered has been connected. So which is assume they are connected. So connected graph is every vertex and connect every other vertex, either directly or indirectly. That is every vertex in this graph are reached from each vertex and in the graph. So for example, graph 1, 2, 3 are all connected. And however, some are not connected at all. So we can see from graph this 1 and 2 and 3, they didn't connect each other at all. Okay. So next thing we're gonna talk about what's a bridge. So a bridge is an edge in the connected graph that if we remove the bridge and leaves the graph become to the disconnected. For example, the graph 1, we connect C and D, but result C and D this edge, and we actually become to the two different graphs and they just disconnected. So isomorphic graphs, and we can say it's called equivalent graphs, which is identical information. That is the same numbers of vertex, same number of edges, and the same connections between vertex. So we can say it's kind of like symmetric graph. So graph 1 and 3 from this, that looks like, sorry, graph 2 and 3, that looks like it's called the equivalent graphs. So which is like they have the same age, same connected, same vertex. And also because the same number of edges, so we have 5 and vertex 4, and corresponding for the vertex the same, we can say graph 2 and 3 looks like a graphical equivalent. And so we say this one, each graph the same numbers, which is edges have 5 and vertex of 4. Corresponding the vertex has the same degree. So degree A, we can see we have 2. And also the edge for joining the vertex the same way. So A to C, A to D, B to C, B to D are actually looks the same, and C to D, D to C. Now we're gonna try to figure out those three. And as an example, the first question, so which three of the graphs are actually connected or not connected? So we can say that both graphs are connected. So the first answer will be all three graphs are connected. And another one, so we can say the graph 2 contains the two bridges. Identify these two bridges. Okay. So I'm gonna restart drawing the graph in 2. So we can see this little triangle. So we can see it's ABC. Come on, man. That was not straight line at all. But this one better. Okay, perfect. So A and C and B, and then connect it from between to D. So this one is actually E, and next point and will be D. Okay, so anyway, that looks like the graph 2. So we will have two different bridges. The first one, if we remove the E to D, they become removed. So that's your bridge 1. So we can say DE is one bridge. And another one, so if I remove this one, so D to E are not going to be connected. So if I move another one, which is E to B, so if I move those one to that, so that becomes the bridge 2, so which is E B is another bridge. Okay. So question C will be saying two of the graphs are isomorphic, which is is like equivalent, and identify those two graphs. So first we can check all these graphs are the same numbers of vertices and edges. So all three graphs have the 5 vertices. So A, B, C, D, E, and A, B, C, D, E, and A, B, C, D, E. And all three of the graphs have the graph 1 and 3, they had 6 edges. So we have 1, 2, 3, and 4, 5, and 6. 1, 2, 3, 4, 5, 6. So we have 6, and then the graph 2 is only 5. 5H, 6H, 6H. So now we check all edges connect the same vertex. So all edges in the graph 1 and 3 connect to the same vertex. We can say D to E, they had twice. And BE, so we can say D to E, they had twice. And then they had B to E, and they also had B to C. B to E and B to C. Listen to this one carefully. And also had A to B. Good. And also they had A to C. So which is graph 1 and 3 have these things. And so which means we have two graphs will be the equivalent, so which is graph 1 and 3. Sorry. Good. Okay. Yeah, so that's called equivalent graphs, obviously it's isomorphic graphs, and we need to know. Next one, we will talk about adjacency matrices. It's a square matrix and using 0 and integer to record the numbers, edges, and connect each the pair and the vertex in the graph. So we can see this one is an example. So A to A, there's no connections, no loops, which is good. But A to B, so A to B, we had one connection, which is 1. A to C, we had one connection. And A to D, we had 2 connections. So there you go. So B, we can say we have one connection to A, which is good. 0 connection between them. And Also, we're gonna have one connection with C, so then we have no connection between D. And next one, we can use the different color. So C had a connection which is a loop. And so C to C will be 1 in here. Sorry, in here. And C to A and C to B also had 1, but no connection between D. And D only had a connection with A, so it's 2 and 0, 0 between. So hopefully that makes sense for you guys. So the 0 row A and column A, and then there is no edge between connection vertex A to A. So and so on. That's the example I just shown you. And now we're gonna using these to graphing our graphs. So we can see it's 5 by 5 square matrix. We're gonna have 5 different how to say that? 5 different people A, B, C, D, and E. Okay, so we might do A, B, C, and D, and E. Start with like that. So first one, A to A is 0, and A to B is 0. So which is we don't have connection between A to B. But A to C, we have 2 rows. We can say 2 rows to C. And A to D, there's no connection, and A to E, there's only 1 connection, which is good. And next one, we're gonna go with B. So B to A, there's no connection. B to B is no connection, but B to C have 2 connections. So we go here, and we go here. And B to D have 1 connection. Good. So I'll go straight line. Okay, perfect. And now C to A have 2 connection. Good. C to B have 2 connection. That's good. C to C, there's no connection. And C to D, there's 1 connection. And also, we're going to have C to E. Nope, we don't have connection. Now, D. D to B have 1 connection. Good. D to C have 1 connection. But D to D have 1 loop. So we go loop. This one. Good. And D to E, no connection. And E only connected with A, so which means that's the graph we know. Hopefully that makes sense. And here is the 8B you just know. And next chapter, we're going to try to figure out how we're going to try to plan out the graph and using the ruler's formula. Hopefully you guys enjoy this. I'll see you guys next time.